Hey guys, this is Taylor here, and today we are solving the second problem of the weekly contest 462, which is maximum key to sort a permutation. So let's read the problem. So you are given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. Okay, you must swap elements at indices I and j only if nums of I and nums of j, their AND operation is equal to k, where AND is bitwise AND operation and k is a non-negative integer. Okay, return the maximum value of k such that the array can be sorted in increasing order. Non-decreasing order means increasing order using any number of swaps. So number of swaps are not limited. If nums is already sorted, I can return a 0 directly, and permutation is the rearrangement of all elements of an array. Let's understand what is given to us. So we have been given an array, something like this. What we need to do in this array, we need to check what all elements are not on its correct place. So according to array, if its length is 4, then I would be having the numbers from 0 to 3. Okay, so this is the condition given to us in my question. Now I can see that I think this 3 is not on its correct position, and 1 is not on its correct position, because 0, 1, 2, 3, I can see this is matching, and these two are not on its correct position. So I need to simply do around the swap in this two positions, and I can get my k. Let me do that. So if I swap 3 and 2, 3 and 1, so my AND operator will give me, I think 3's binary is 1, 1, and 1's binary is 0, 1. If I do AND operation, I will get a 1. So my k is equal to 1. And if I do this, my array is sorted. And that's what I have to do, right? Now you must be thinking that how we'll be solving this problem, how we'll be identifying what all numbers are there, and we have to find the maximum k. That's a lot of things, right? So give me a minute, we will simplify everything. Okay. So I hope you understood the problem, and the very important thing here is, so k must be same. Okay, must be same for all the swaps. So this is very important condition. If you understand this, you will be able to come up with a solution. So this is actually not very clearly mentioned. They have mentioned that you can only swap if nums of I and nums of j equal to k, and you need to maximize k. But I would suggest that the question should explicitly mention that k would be same for all of the swaps. Then we will be easily able to come up with a approach or intuition, or basically understand the problem. Just to understand this problem, I would be just telling you the solution first, then we'll be understanding why that solution worked. Okay, so I would be just briefly telling you the solution. So if let's say we have some array like this, 0, 1, 2, 3, 5, 6, 7, 4. If we have given some array like this, so I think these four elements are basically not on its correct position. 4, 5, 6, 7. The correct order is this. So what is the answer of this? How would be getting the answer? So I would say 5 and 6 and 7 and 4. So this will be answer. So whatever the answer we would getting after AND operations in all of these four numbers, that will be our answer. So that will be our maximum k. Okay, maximum possible answer. Now why that works, let's see. But this is the answer. Okay, so it's that simple. If we are able to calculate the AND operations for all of the elements which are not on its correct position, then we'll be able to find the answer. So here I have written my array, and we have been given in the question that we have to perform the bitwise AND operation, right? So whenever we got some question which is around bitwise AND operation or any bitwise operation, so their answer lies in bits only. So we have to think in terms of bits, like how we can solve the problem, and we can think of, let's say, AND or XOR operations also. But in this problem, the problem is not that much complex, and only the AND operator is able to easily solve this problem. To solve this problem, I need to find a k. Okay, so I need to find a k, and that k should be maximum. That k should be maximum. And how I would be finding the k? By bitwise OR. Okay, bitwise end, sorry, bitwise end. Bitwise end would help me find the k, and I need to maximize this k. Now, let me first determine that whether it's actually possible or not to sort any array. Let me see that. Okay, so if I write some random array like this, let's say 0, 1, 2, 4, 6. Okay, let me write some array 6, 5, 4, 2. Okay, so here is my array, and if I need to swap these elements, and let's say in the worst case, in the worst possible scenario, like these numbers are not like by uh, getting a bitwise AND operations among themselves, they are not giving me equal answer. So would it be even possible to sort this array? I would say yes, it is possible. Let's see how it is possible. So in the worst case, in the very worst case scenario, what I can do, I can bitwise every number with 0, and that way I would be swapping this number with 0, right? So let me swap this. If I swap this number with 0, what happens? So I would get something like this: 7, 1, 2, 0, 6, 5, 4, and 3. And what I will do, I will again swap this 0 with this 3. Okay, so let me do that. 7, 1, 2, 3, 6, 5, 4, and 0. Now I would swap this 7 with 0. Okay, let me do that. 0, 1, 2, 3, 6, 5, 4, 7. So that way, you can see that in three operations, in three swaps, I'm able to put 7 on its correct position, maintaining 0 on its correct position. So in that way, like that way, I think I can put this also at its correct position, this also, and number of steps are not at all limited. So that's why my answer can be definitely possible. And maximum, if in the worst case, in very worst case, the maximum possible answer, definitely I can get a 0, right? So I would say yes, definitely it is possible to sort array in any condition. So okay, so this is the condition one. So let me, if I tell you two, three couple of things, you will be able to definitely solve the problem. First condition is key sorting is possible. Okay, so the second condition is, so how to find out, how to come up with the second condition. So let me bring some example. If we try and two, three examples, we will definitely able to understand. Okay, so let me say 0, 1, 2, and 4, like 6, 5, 4, 4, 6, 4, 5, very nice. Okay, so you can see that I think these three numbers are not on its correct position. 4 should be here, 5 should be here, 6 should be here. Now to sort this array, what I need to do? I need to put 4 on its correct position. That means one swap is required. I need to put 5 on its correct position. That means again one swap is required, and 6 at its correct position. Again one swap is required. Now let me write the bitwise. Let me write the bits for this. So 4 I think is 1 0 0. 5 is I think 101, and 6 is I think 110. So these are basically the binary representation of these numbers. Now I need to swap these three numbers only. Are you sure that I need to find swaps between these three numbers? Yes, I am. Yes, I need to. And I can swap any number of time, right? So I can swap this to this, this to this, this to this, right? Definitely I can do. So if I take bitwise AND of these three, okay, let me take bitwise AND, then we'll see why it worked bitwise AND. So it is 0, it is 0, and it is 1. So I am getting a 4, means 100 as my answer. So why this worked is basically, so my minimum number, this is my 4, right? This is my 4. I need to put this number at its correct position. And to put this number at its correct position, what I need to do? I need to swap this. And if I would be swapping this number, this 4 at its correct position, I need to do a bitwise AND operation. And if I need to do a bitwise AND operation for this number, this minimal number, definitely this would be my answer. Why it is my answer? So let me again tell you. So this is not like a minimum. Okay, this is not I am taking minimum of this number. This is basically using this. What is the minimum one count? Okay, so that's why I am able to find out the answer. Let me tell you again. So what we are doing here in this question, basically, so I know 4, okay? 4 I am having, 6 I am having, and 5 I am having. Okay, I need to put 4 on its correct position or not. Yes, I need to. And 4 is having 100 binary bits. Okay, 5 is having 101 binary bits. 6 is having 110. If I need to put this 4 on its correct position, do I need to swap this? Do I need to perform AND operation or this or not? I need to perform AND operation on this. So 100. I need to perform something AND. Okay. So whatever this number is, if I'm able to I am able to perform AND operation with all of the numbers, would I get some number which will satisfy all of the swap conditions or not? I think yes. So whatever number I will be getting now, so if I'm getting 4, so if I get 4 now, so that will be the minimum. That will be the minimum possible answer, which will be swapping all of these numbers. Okay, which can satisfy all of these numbers. Not minimum, I mean maximum. So let me take one more example. I hope we'll be definitely able to understand why this question, why this approach worked. So what I'm doing, let me write the binary of 3, which is 1, 1, I think. 4's binary is 1, 0, 0. Let me put a 0 here. And 2's binary is simpler 0, 1, 0. Okay. Now what I need to do? I know one thing that this is basically 0, 1, 0. This is 1, 0, 1 and 0, 0, 0, 0, 0, 1, 0. Okay. Now I need to just calculate the AND operation for all of this. So it's I think 0. This one is also 0. This one is also 0. I'm getting all zeros. Will it be my answer? I think yes, this will be my answer. You know why? Because in this part, I think these two parts are 0. That means this part will definitely be 0. This 1, 0 is 1. This part is 0. That means this will be 0. And this is 0. This is 0. That means this is 0. Now, why this is the only possible maximum number? You know why? Because I need to swap this to this. I need to swap this to this. Okay, these three numbers I know that are not on its correct position. I will not involve this because these are on their own correct position only. So these three numbers I need to swap. Yes, I need to swap these three numbers. And to swap these three numbers, what I need to do? I need to perform AND operations on this on this among all of them, right? And whatever way, whether I perform 3 and or 4 and or 2 and 3 and or 2. So once I perform this now, by only one operation the answer will not come. I need to perform multiple swaps, right? Definitely, then only I will get my answer. That's why it is proved that the answer to get maximum possible k is basically to perform to get the end operation on all of this. I think I'm able to explain you why it is important. I can bring one more example. Let me write now. Let me write binary of this quickly. Two's binary. So I think this part is basically which are not having or not are on its correct position. So two's binary is 1, 0. Okay, so I have written binaries of all of these numbers. Now to get my answer, what I need to do, let me write something like this. So let me put a 0 here, 0 here. Super. So 0, 0, 0. So this will be 0. 1, 1, 0, 0, 0. This will be also 0 and this will also be 0. So again, I'm getting a 0, all zeros. So what we have done here is basically I need to swap all of these numbers, right? I need to swap all of these numbers. And to swap all of these numbers, what I need to do? I need to swap 2 with 3 or 6 or 5 or 4, right? I need to perform 2 and with either 3 or 4 or 5 or 6. Okay. Now I need to perform either 3 swaps, 3 and with either 2, 4, 5 or 6. Any of this number, right? I need to perform 4s and with either 2 or 3 or 5 or 6, right? I need to perform any of these operations and there will be definitely multiple swaps, multiple operations. That's why our answer will be definitely lying between the end of this all of the numbers. So that will be the minimum number that I would be getting. That minimum number is basically maximum k. Okay, that minimum number is basically maximum k that can satisfy all of the swap conditions. I hope I am able to explain you why this question is like this. So let's write pseudocode for this. If you have any doubts, any small doubts also, so please let me know in the comment section. If you don't know what is a bitwise operation, bitwise AND operation, so bitwise AND operations is basically if I'm performing bitwise AND on two numbers, so if both of the numbers are 1, then only I will be getting 1. Otherwise, I will be getting 0. Okay, so 0, 0, this is separate. Okay, The 1 and 0 is 0, 1 and 1 is 0, 0 and 1 is 0, and 0 and 0 will be also 0. So this is basically definition of simply bitwise AND operation. So let's quickly write pseudocode for this question. So I would be defining my bitwise and something like this, a none. Okay. Now what I will be writing? I will be writing for I equal to 0 to length of array or nums. Now what I need to do? If array of I not equal to I. That means it is not on its correct position. Now I need to check first of all if bitwise and equal to null or null, whatever you can say. If it is null or none, then what I need to just assign this value. Okay, bitwise and would be equal to array of I. Otherwise, what I need to do? I need to just perform bitwise and operation. Simple. Bitwise and would be equal to bitwise and my array of I. Okay, so this way I will be easily able to calculate my answer. And in the last, I need to return my bitwise end. So after doing all the bitwise end, I need to perform my answer. Now there is one more edge case to handle. That edge case is simply lies here. So I would be writing something like flag equal to false. And if there is, I'm writing here flag equal to true. Okay, and what I'm writing? I'm writing and flag. So what I'm doing here is basically, let me explain you. Okay, so uh when will this condition execute? Array of I is not equal to I. I think that will execute when when it will execute when number is not sorted, when number is not on its correct position, then only it will execute. So if my flag is still false, what I need to do? I need to return a zero, right? Is it or not? So if my array is already sorted 0, 1, 2, 3, 4, that they have given us. Okay, if return the maximum, if nums is already sorted, return 0. So that's what I'm checking here. So I'm not writing extra loop for this to check first, then if it's not sorted, then comes here and do. I'm just maintaining one flag variable here. And if at least one time I'm able to find out this number that it's not on its correct position, I will make it true. Otherwise, I will keep it false. And if it is kept false, I would be definitely writing a zero here, and a zero and or whatever answer I will be getting, I would be getting answer final answer of zero. Okay. So this is the whole intuition and approach behind solving this problem. If you are still having this doubt, I would suggest first to try run yourself. If you are not able to find out or you are having some doubts, please feel free to comment in the comment section. Okay, so let's write code for this quickly. So first I would be writing something like this. Now bitwise and would be starting from none. And flag would be starting from false. Okay, now what I need to do? I need to iterate over the array. And what I need to do? I need to check whether current number is on its correct position or not. If it is not, what I need to do? I need to check whether if bitwise and is set or not. If bitwise and is none, that means I need to simply assign this number to bitwise and. Okay. Otherwise, what I need to do? I need to perform AND operation, right? So let me perform the AND operation and array of I, and I think this should be nums, not array. Nums, nums, and nums. Super. And after performing all of this, I need to return my bitwise and. But there is one edge case to handle, whether I would be writing something like this. And here, what does that mean? As we discussed, this flag is false. That means my array is already sorted. If if at least one time I am able to find a number which is not on its correct position, I will be setting this flag as true. Okay. And I would be writing something like this or flag. So what does that mean is, if I am able to find out a bitwise and, okay, if I am able to find out a bitwise and, if my bitwise and is not none, that means it come here, okay, and it got some answers. Okay, so if I'm able to find out my bitwise and, I will be returning that. Otherwise I will be returning a zero. Otherwise I will be returning false. False means zero only. Okay, so if I write something like this, that will definitely work. Okay, it's not working. Okay, I should return a 0 here. Oh, yes, it is working fine. So I was returning false, but it is considering it as an integer, so it was not taking that. So I should return a 0 itself to make sure that it is a 0. It's not a integer. Okay, it's not a Boolean variable. So previously it was returning a Boolean variable. So if I try to submit this, okay, it is working fine. So I hope you are able to understand this problem. And if you are stuck or if you have any doubts in this part, why performing AND operations on all of these numbers are getting us answer? The answer is very simple. The answer is lies behind this problem only. So if I have to do AND operations among all of these numbers, that means that I I would be getting something like my answer would be around these numbers only. Okay. So whatever my minimum number is, I need to swap all of this. So minimum is not like this minimum. Okay. Minimum is something like the minimum number of ones. Okay. So here you can see that all zeros, all zeros, all zeros. So that's why I got 0. But in this case, I got 100. Why? Because here all 0, here all 0, but here I got all ones. So that's why my answer is this. Okay. So I hope you got it, and if you like the video, please make sure you subscribe the channel. That will motivate me for creating more such videos. Okay, thank you very much, guys.